Pugnacious programmers, are you ready to bip the guy? Well, you'll have to wait a bit, because before we can begin building the Bip the Guy app, we're going to build a smaller app named UIViewAnimate to learn some basic concepts that will help us in this app and beyond. Now, we'll also introduce some things that I've seen trip up new students over the years, as well as how to better understand iOS behavior and not let any unexpected strangeness slow you down. Now, in this first app, we're going to quickly set up an interface, and we'll use this across this and the next video. It's just got an image and 4 buttons in it. Now, we won't do any real animation until the next video, but we will move items around the screen, off screen, and back on. But we'll also discuss the interface builder object placement hierarchy, the iOS coordinate system, the CG float type, points, origin, center, frame, bounds, and rects. We'll recognize gotchas when getting coordinate values from constraints versus auto-resizing, a discussion of the override and super keywords. We'll get a first look at the view controller lifecycle methods, ViewDidLoad, ViewWillAppear, ViewDidAppear, and the ViewDidLayout subviews method. Let's code! So here is what we're going to be doing to set up the project. It's pretty basic. I'll go through this right now very quickly. You're welcome to pause if you want to do this on your own and not follow along with the video for setting things up, or you could look at this as a challenge, but you should be familiar with all the techniques we're about to use. So let's build. Now I've got a folder with some assets for the entire chapter and the 2 projects that we're going to be working on, so why don't we head there right now. Go to the URL bit.ly/prof-g-swift-files, all lowercase. That'll bring you to this Google Drive. Click on the Bip the Guy files folder, select download. Your browser will either automatically download this likely to your downloads folder, or you'll be asked where you want to save it. Mine's asking me where to save. I'm going to save that to the desktop, and I'm going to give this zip the name Bip the Guy files and click save. Then I'll go to the Finder, double click on the zip file to expand it. I can throw away the zip file now. I'm ready to open up Xcode. I'm going to create a new Xcode project, a single view project. Next. I'm going to call this UIViewAnimations. Make sure it's a Swift project. Make sure it's a storyboard project. Next, make sure that your Git repository is going to be created and click on Create. I'm going to save mine right to the desktop. Then expand Xcode to full screen by double-clicking on the title bar of the window. Click on Assets Catalog. Return to the Finder. Let's open up the Bip the Guy files folder that you just extracted. You don't have to worry about the app icon set yet. That's for Bip the Guy, not this demonstration project. Now you could use any image that you'd like, but I'm going to grab this clown PNG, which is going to be the image that we're going to be bipping when we finally get to our Bip the Guy app. This was created from the clown emoji, but if you find clowns just a little too frightening, feel free to use whichever image you'd like. Now click on Main Storyboard. Let's click the library, add an image view. I'm going to click the size inspector, set the width and the height both to 100 points. Then I'm going to click back on the attributes inspector, and I'm going to set the image to my clown image. I'll drag the image over to position it on the center line, click the library and add a button. I'm going to change the button name to Move. Click the size inspector and set its width to 100. Click back on the attributes inspector, and I'm going to change the button color. So down here, I'm going to set the tint from the default blue to white color, and I'm going to set the background to, you can really choose any color. I'm going to choose maroon, one of my recently used colors. Then I'll position this along the horizontal center line. Command D to duplicate the button, then I'll select both of those buttons, Command D to duplicate them again. Now I've got 4 buttons positioned along the center line, and I'll change the titles for these duplicates to Alpha, Pulse, and Color Change. Then I'll click on View Controller, Option click on Main Storyboard so that I can create IB outlets. So I'm just going to control drag over from the items to create the outlets. The image view is going to be named Image View. The Move button is going to be named Move Button. And here's another technique that just might save a couple of seconds when creating IB outlets of the same type. Since the next 3 outlets are identical to Move Button, except their connection is different and their name is different, I'm going to select this entire line where I've defined Move Button, copy it with a Command C, then Command V 3 times to paste 3 copies down below. Now you'll see briefly that the circles that indicate connections look all messed up on the side, but we'll change that in just a bit. I'm going to go ahead and rename these copies that I just made 1 Alpha button, 1 Pulse button, and 1 Color Change button. After you do that, you see empty circles on the side indicating that there's no connection, so I can just drag, not control drag, from the empty circle in my code, create a rubber band line, and let go on top of the interface item I want to connect it to. You see, each time I do this, the little connection ball gets filled in with a black dot. Then down below, we'll control drag from the Move button. I'm going to name this IB action Move Pressed, set the type to UI button. Then I'm going to use the same technique that I used on IB outlets with IB actions. I'm going to copy the IB action that I just created for Move Pressed, Command C. Then I'll Command V 3 times down below to create copies. and rename the first copy alpha pressed, the second one pulse pressed, the third one color change pressed, and I can drag, not control drag, from the empty circle to connect it to its respective button that's attached to this action. And when you hover over the little circles that are where the line numbers are, you can see that a little black tag shows up next to the item on the interface builder that it's connected to. Yep, the correct button is connected to each of these actions. And just to triple check to make sure that we don't have any broken connections, I'm going to right click on the yellow ball in the dock area of the view controller, and in this connections dialog, I can see I've got no yield signs. A yield sign would indicate we've got a problem. Let's continue. Now, I want you to return to the main storyboard. I'm going to demonstrate something that I learned the hard way and that I haven't seen explained well in any tutorials or documentations, and it took me a while to figure out what was happening. So we're going to create this potential issue so that you can recognize it if it comes up, and it'll also give us a chance to talk about an important concept called the view controller lifecycle. Now, the issue we're going to demonstrate is when constraints take effect for positioning versus auto-resizing. And in order to demonstrate this, we'll show both techniques. First with auto-resizing, so we're going to use auto-resizing through the hybrid technique we learned in our first app. Now, when I set this up, I also want to point out the hierarchy of items that are layered on the storyboard. So I'm going to first go to the library, type in UIView so that I pull up an empty view. I'll drag this over, drop it on my view controller, and I'll resize this so that it takes up approximately where the safe area is in the view controller. Now you can see the other items have disappeared. That's because I've actually drawn this view on top of those other items. The view at the top has white as its background color, so it's obscuring the things that are below it. Now notice the position of this new view in the document outline on the left. The items in the document outline are actually listed in reverse order. So the bottom-most items are actually at the topmost at the bottom. So our new view is down at the bottom, and you can actually change an item's location relative to the others by dragging it to a new location in the document outline. So I'm going to click and drag this view until it's above the other objects. This positions this view below those objects. Now the image view and the buttons aren't embedded in that view yet, but you can also embed them in directly from the document outline, although we'll run into a bit of a snag. But I want you to see that this is possible. So I'm going to click on the color change button, hold down the shift key, and click the image view. So now I've selected everything that should be on top of this new view. Then I'm going to drag this entire selection just a little bit up and to the right. Not so much that these items go on top of the new view, but you can see there's a little blue indicator line and a tiny circle on the left that indicates it's indented just a bit. Now this indicates that I'm about to embed the selected items into the view that's shown in the document outline just above where this little blue line is. And when I let go, I can see these items are now indented slightly, and there's a selection triangle to the side of the view indicating, yep, these guys are now inside the view, they're embedded in the view. Unfortunately, I've also lost the positioning of the embedded objects. I could drag them around and reposition them, but instead I'm going to go back and use our old embed in technique that we had previously used. So I'm going to select Command Z to undo the move. Then I'm going to Command Z again. That puts the view on top of the image view and buttons, so it's showing up at the bottom of my hierarchy. Then making sure that the view is clicked, I'm just going to press the delete key to delete it. Now again, I wanted to show you this because I've seen students working with user interface elements and wonder where their stuff went, only to not recognize that there were other interface elements positioned on top of their existing items. Hopefully now you know to check the hierarchy of things in your document outline if it looks like something's being lost. But now let's go ahead and use the embed in that we'd used previously, and this will let us keep our image and buttons in their current location. So I'm going to draw a selection rectangle around the buttons in the image view. I'm going to go to the lower right hand corner, click on the embed icon, select view, and we see these are now in a view. See, there's now an expansion triangle next to view in the document outline, and when we click that, we can see all 5 items in that view, but that view is not taking up the entire safe area like we'd like, but we can change that. So I'm going to click and select the view and make sure it's the view that's selected and not any of the items inside of it. And I'm going to pull it down just a little bit to make sure that I'm not overlapping with the safe area. This will allow me to constrain to the safe area. Then I can go down and add 4 constraints, and I'll do 0, 0, 0, and 0 for top, left, bottom, and right. Click on the arrow next to the top. I can see, yep, I am definitely constraining to the safe area. That's what I want. Click add 4 constraints, and oh, things still moved over to the left, but I can command click on all 5 of these items, just drag them over to the right so that they're on the center line, and they're good. With all of these guys selected, I'm going to click on the size inspector, and I'm going to set up auto resizing as you see here, where the only red line that's selected is the top center line. These will keep things centered horizontally in the container. And then I can take a look to see how things look on devices of different sizes. They're looking good. I happen to be working on an iPhone 11 Pro format here, so I'm going to keep that. And if you want to double check, you can go ahead and build and run now. None of our buttons do anything, but we've got our interface set up and we're ready to start coding. So we're going to make our interface elements move around screen, and first it's important to understand how the iOS device coordinate system is structured. So 0, 0 is the upper left-hand corner. Unlike high school geometry, where the origin was in the lower left-hand corner, we're upper left. Now if you want to move right, add to X. If you want to move left, subtract from X. If you want to move down, add to Y. If you want to move up, subtract from Y. Now you'll also need to understand some key data structures. First, most of the structures that we're talking about commonly use a data type called CG float, so not ints or doubles. And while there are some ways to use doubles, for example, to define the rectangles that make up an object's borders, most of the time we're using these things called CG floats. Now for purposes of our work, CG floats are a lot like doubles. They have decimals, they can have negative as well as positive values, and you can convert between doubles and CG floats the same way you could convert between most other types of numbers. Now everything that's based on a UI view, so that means anything you can see on your iOS device, whether it's the view itself, buttons, labels, images, all those things have a rectangle that define the boundaries of the object. Now these rectangles are referred to as CG rects. That's the data type. The CG stands for Core Graphics, which is Apple's main graphics framework. And there are a lot of different ways that you can define a rectangle, but the one you're likely to see most frequently is one that uses X, Y, width, and height. And again, X, Y is the upper left-hand corner. Now, there are two other terms that you'll hear of when referring to rects. Any subclass of UI view, again, buttons, labels, all of those things, have a frame property. Now, this is the rectangle as identified as to where it sits inside the border of the view that it's inside of. So take a look at this iOS device here. The main frame at the base level of this view controller is going to be 375 by 812, because that's the dimensions of the device. Now, this image view with a creepy clown, it's at position X 138 and Y 80, and it's got a width and height of 100 each. Now there's also a bounds rectangle. That's the coordinates of the view within its own coordinate system. So the bounds of any particular object usually has an X and a Y of 0, 0. And the width and the height of an object is typically the same whether we're looking at the frame or the bounds. Now each object also has a center, which is a center point, and that's also got an X and a Y value. That'll tell you where the midpoint of the object is with respect to its parent view. So now that we know a little bit more about the iOS coordinate system, we can use this to move objects around our screen. Now for our first attempt to move an item, when the move button is clicked, we're going to move our image view by setting its frame.origin.x property to 5, which would position it 5 points from the left border of its super view, which is also 5 points in from the left of the device. So let's write the code, and hopefully things will be clear to you. Inside our moved press IB action, we're going to type image view, because that's what we're going to move. And there are a lot of ways that we can position it to the left, but what we'll do is we'll refer to the image view's .frame.origin.x property, and we'll set that equal to 5.0. So let's build and run. Here is everything centered, and now I'm going to click on move, and whoa, there goes the clown. Its X value, its leftmost value, is now 5 points from the left of the view. Nice. Now this wasn't really animation. We instantly moved an item from one point to the other. We're going to learn how to do animation in just a bit, but first we want to make sure that we understand the coordinate system. So another challenge. So we're still going to work within move pressed, but I want you to remove the code, or you can comment it out if you'd like, that code that you just wrote to move the image to X equals 5.0. And I want you to write code to move the image and all of the buttons except for the move button off screen to the right. Now here's a hint. What's the X coordinate of the far right point on the device? How can you get this value? And if you need to, take a look at the earlier slide that shows you the coordinate system. So you know what time it is. It's time to pause, give it your best shot at coming up with a solution, and resume, and let's take a look at an answer. So let's first create a constant to hold the device width. So we'll say let device width equals. Now how do we get the device width? Well, if we refer to view, we're referring to the main view on this view controller, .frame.width. Now I'm going to highlight device width, and I'm going to replace 5.0 with the device width. And so think about this. This takes the left-hand side of image view, that's what origin.x is, and it puts it on the right-hand side of the super view, which is the width of the device. Image view is still there, but it just exists in a space that's just over the rightmost border of our view controller. So now I'm going to copy this line where I set the X value for image view to device width. I'm going to paste it down below 3 times. Then all I need to do is change the object name. So the second one is alpha button, the third one is pulse button, and the fourth one is color change button. So let's build and run. If I click on move, everything except for the move button should be moved off to the right-hand side of the screen so we can't see it. Here we go, click, boom, it worked, fantastic. Next, what I'm going to do is I'm going to position everything except for the move button off to the right so that you don't see it, and then when you click on the move button, what I want to do is move them back to the original position so you can see all those interface elements. The way that I'm going to do that is I'm going to highlight all of the code that's inside of moved press, cut it out with a Command X, I'm going to paste it into ViewDidLoad, and this code moves all 4 of those interface elements off the right-hand side of the screen. But what I want to do before I move them is I want to keep track of where the original X position is. I want to save that to a class-wide property because that's the X position that I want to move everything back to when I click on Move Pressed. So let's head up here and create a class-wide property. We'll say var, we'll call it original X, and I'll declare it, but I won't initialize it. So I'll say colon, this is of type CG float, and I'll put an exclamation point for it to be an implicitly unwrapped optional. And now I'll initialize this at the top of ViewDidLoad, right after super ViewDidLoad. I'll say original X equals image.frame.origin.x. Sorry, this should be image view, not image. Then I'm going to highlight these 4 lines here that move things over to the right, copy them with a Command C, paste them down inside of Move Pressed, but instead of setting them all to device width, I'm going to set them all to original X. That'll bring them back. Let's build and run. Again, no animation. These things are positioned instantaneously, but we're understanding how to work with the coordinate system for iOS devices. Our app runs. The 4 items have been positioned off the right-hand side of the screen. Click on Move, and they all return to the original X. Nice. Now I want to show you how we can accomplish things using the center point of our view as well. So in ViewDidLoad, I'm going to delete this line that assigns original X to the view's origin X. I'm also going to be able to get rid of this class-wide property. And the reason I'm going to be able to do that is I'll just refer to the center property for the view. Now I could type in, instead of original X, view.center.x, but instead I'll create a local constant for that. So I'll say let centerx equals view.center.x, and then I'll replace original X with centerx. Now I don't want to assign centerx to frame.origin.x, I want to assign it to the centerx property of each of these 4 different interface items. So I'll highlight centerx and I'll paste over frame.origin.x in each of them. Build and run, click move, same result, we're just working with the center.x property instead of frame.origin.x. Now currently in our app, we're using what we call the hybrid technique for auto layout, where all 5 of these interface items are embedded in a view that's then constrained to the safe area. And it's a hybrid because the 5 items on the inside aren't constrained at all, they use auto resizing. Now I'm going to show you that auto resizing and constrained items behave differently in terms of when their values are set when an app launches. And this has important implications because sometimes you're looking to get coordinates of a constrained item, and if you use ViewDidLoad, you won't necessarily get the right value. Now, I've actually been confronted with this problem and spent a lot of time trying to figure out what was going on. You actually have to dig pretty deeply in Apple's docs to figure out what's happening, and I haven't run across any good online tutorials that raise these issues, especially when talking about animation in the iOS coordinate system. So hopefully we'll save you some time, and we'll also get a chance to offer an initial taste of what's called the view controller lifecycle. Now to show the difference, I'm going to first remove the view that these items are embedded in. You don't want to just click and delete the view because that'll delete the items inside it. And if you drag the items out from the view they're embedded in, they'll lose their position on screen. What you want to do is you want to highlight just the view that these objects are embedded in, and then go to the Embed menu in the lower right-hand corner and select Unembed. The view goes away, but the objects that were in the view don't move. So I'll quickly reposition things and show you how you can set constraints super quick. First, draw a selection rectangle so that you select all 5 items at once. Add new constraints. Now you'll see in some of these spots, instead of having a number, it's got the word multiple faded out. The reason for that is because we've selected multiple items, and collectively they don't have the same numeric value. But that's okay. And that's because if you click to set these constraints, Xcode will simply use the values that it can read from the interface builder canvas. Essentially, it sets constraints based on what you're seeing on screen. So I'm going to click on width, height, and the top alignment line. Since we have 3 constraints for 5 items, notice it says add 15 constraints. You want to click on that. And the reason we're having red lines here is we also need to center horizontally in container. So click align, click horizontally in container, then add 5 constraints. You've just constrained everything. You can click devices of different sizes, but everything is looking good. Now we're going to build and run, and remember what's supposed to happen. In ViewDidLoad, we move 4 of these interface items off the screen. But hey, nothing's moved. What's going on? Well, let's head over the code and try some things out. So ViewDidLoad is the method that we get every time we create a new view controller. Now what that method does is it will run after this view controller is loaded. Just because a view controller is loaded doesn't mean that everything on that view controller is positioned where it should be. And in fact, constrained items aren't guaranteed to be where they're supposed to be until the view has appeared. Now, fortunately, there's a method called ViewDidAppear, which will fire when the view has appeared. So just to give you a sense of how the coordinates are changing during these different methods, I'm going to add two new methods. One is ViewWillAppear, and that fires just before the view appears. And then I'll add another one below that, ViewDidAppear, and that's that one that runs as soon as the view has appeared on screen. Now, we haven't talked about the keyword override that Xcode adds in front of some functions. It adds override in front of functions that iOS has already defined. Now, the word override is saying, hey, I'm going to take one of these Apple functions and I'm going to add my own stuff to it. Now, with some overridden functions, it's okay to just go ahead and write your own stuff. Xcode adds the override keyword where it's needed. You don't even have to think about it. But in other functions, you've got to make a call to Apple's function. In fact, sometimes you have to do that as the first line in the function before your statements can run. And that call to Apple's function is made by saying super dot the function name, and then it's a straight up function call where you've got to pass in any parameters. And you can just usually reuse any parameter names that are in the original overridden function definition above it. Now, how do you know if you have to keep the call to super in there? It would be nice if Xcode added it where it was needed. Unfortunately, it doesn't, but it does say in Apple's online documentation. I'll show you examples of this in just a bit, but in all of our tutorial videos, I'll let you know when you need to include super, and we'll do that together. And notice Xcode already put super in ViewDidLoad. We also need a super call in ViewWillAppear and ViewDidAppear. So let's do that right now in ViewWillAppear. I'll say super.ViewWillAppear, press return. Notice it wants a parameter for animated, but we can just reuse the parameter animated that was part of the function definition above, and that's it. Now it's the same thing in ViewDidAppear. We say super.ViewDidAppear, press return, and put in animated as a parameter. So now to see what's really going on here, let's put in some diagnostic print statements. So up in ViewDidLoad, just after super, I'm going to say print. Then I'm going to highlight ImageView frame.origin.x as our example, copy it, and then back above this, in between the double quotes in the print statement, I'll say ViewDidLoad original, then paste in ImageView.frame.origin.x equals, then string interp, and then inside the string interp I'll paste in ImageView.frame.origin.x. Then I'll copy this print statement, paste it after I've moved all of these items, but still in ViewDidLoad. So now this is the last statement in ViewDidLoad, and I'll change the print statement so that it says ViewDidLoad after device width. This way I should be able to take a look at the original position, and then after setting x equal to the device width. Then I'll highlight and copy this print statement, paste it down in ViewWillAppear, and I'll change in the print statement where it says ViewDidLoad to ViewWillAppear, and I'll get rid of after device width. I don't need that there. Then I can highlight this print statement, copy it, paste it below the super in ViewDidAppear, and in this print statement I'll change ViewWillAppear to ViewDidAppear. So now we can build and run, and we'll watch the console because I've got 4 different diagnostic statements to let me know what the value of the x coordinate is on our items with the original x value in ViewDidLoad. Then after setting the x to the device width, and also printing origin x in both ViewWillAppear and ViewDidAppear. And so let's take a look at the output. ViewDidLoad original for the ImageView frame origin x is 138. That's before things have moved. After we assign our device width to that value, it changes to 375. ViewWillAppear says that that value remains 375. Look what happens in ViewDidAppear. It bounces back to its original constrained location. Now rounded up, this is 138. You don't have to worry about this tiny fraction. But importantly, this is what can happen with constraint setting. The constraints could pull things back in ViewDidAppear, even if you've changed an item's coordinates in ViewDidLoad or ViewWillAppear. Well, this is really important to know. So what we'll do is we'll cut out all of the statements in ViewDidLoad except for the print statements. We can highlight and delete the print statements. I don't need those diagnostic print statements in ViewWillAppear, ViewDidAppear either, but I'll paste the statements that move the interface items into ViewDidAppear. Change will happen fast enough that we won't see a flash on screen. It'll look like the things have never appeared at all. And I'll put in a comment here just to remind us, ViewWillAppear is called after UIKit has laid out subviews and displayed them. Let's build and run. Now we see right at the start of our app, everything is off screen except for the move button. Click move and things pop up on screen. Nice! Now I want to cover one more thing that's related to the view controller lifecycle. So sometimes you want to detect if the orientation has changed. Well, the methods we've introduced don't do that. If you click on the rotate button at the top of the simulator or press command right arrow as I'm doing here, the interface elements remain where they are even though the orientation of the screen changes. Command left arrow orients the screen 90 degrees in the other direction. Well, if you ever want code to execute when the orientation changes, there's a method for that. Just call ViewDidLayout with subviews. To show you how that works, I'll just add it right here in my code after ViewWillAppear. Now, I mentioned Apple's documentation will tell you if you need to call super. Here's the page for that method. It says the default implementation does nothing. That means that we don't need the default implementation, which means we don't need to call super. And just to compare that, if we took a look at the page for ViewDidAppear, see how it says we must call super? So if you're unsure if you need to call super, just check the documentation online. So just to see how this works, I'm going to take the code from ViewDidAppear, cut it out, move it up to ViewDidLayout with subviews, build and run. Now this method does fire when the app first runs. That's why we don't see any elements on screen. Press the move button. Things move on screen. Now let's change the orientation. I'm going to press Command right arrow, and look at that. The things move off screen. Click move. They move back. Click Command left arrow. Now that rechanges the orientation to standard portrait mode, and we see the code in ViewDidLayout with subviews executes again, moving the elements off screen. Nice. Now that's not exactly what I want, so I'm going to take the code from ViewDidLayout with subviews and move it back to ViewDidAppear. Well, now that we've got some solid knowledge of the iOS coordinate system and how the view controller lifecycle influences those coordinates, in the next video, we're ready to animate.